Good morning, students. Today's agenda is software-defined networking. Hopefully, you all are doing well. In today's topic, I will cover two basic things. What is software-defined networking? And second one is the architecture of SDN. Software-defined networking is playing a very important role in current age because due to the demand of the users, the infrastructure is, will change drastically. Uh, Currently, we are looking for 100 Mbps to 200 Mbps, and now we are going to the 1 Gbps data demands. So every time infrastructure change is not feasible. So before the deployment, software-defined network will play a very important role. As far as the Internet of Things concerned, we know a lot of devices are connected with the internet day by day. So huge number of data traffics demands. So which type of networks will be suitable for the IoT that will tested by software-defined networking? So how we can define the software-defined? The name itself, software-defined, means software that is the some programmable part, and that can have a they can be reconfigurable anytime. So here we have already defined the how you can define the software-defined network. That means a network that allows service provider to customize the infrastructure dynamically as per the application requirement. So 70 to 80% cost of the any NSP provider is involved to build the infrastructure. To change the one infrastructure to other infrastructure is very tough. So, so researchers first test the system on the basis of software-defined network. I just give the one example. Let us there is a one technology 3G and then the 4G, and currently we are testing in the testing for the 5G. It is possible that every time the infrastructure will change, your tower will change. No. So how we can test? That is the software defined will provide the platform. This is the basic concept, and this software defined is deals with the both types of network, infrastructure or infrastructureless. We all are know infrastructureless. This means that is reconfigurable network, manage like that. And infrastructure based network is wired and wireless both. We know access point, which will always supported by the optical fiber network, and that is the best example of wireless network, but based on the infrastructure networks. And the conclusion of all this to optimize the network, that is the optimized utilization of the underlying infrastructure of the resources. This is the basic clue of the software defined network. After this, here the some data which will provide the platform why SDN is required. So from 2014 to 2019, there is a rapid growth of internet traffic, near about 23%, and might be the recent data is near about 40%. And all this data is uh, taken from my research papers. So I will also provide the link where you can get this detailed data. At the same time, mobile connected devices are increasing day by day. Now, one person have, I already told in many times in your class, one person have at least two same, or two mobiles have the four same. So you can think how much traffic the data is required. In the morning times, when you send the message of good morning, or just think about the 1st January, Happy Diwali, message, how much data traffic has been transferred in one application like WhatsApp. So we are we are the user just sending the message. We don't think how this will be controlled by the any networks. So this huge data traffic should be controlled by some mechanism, and that is the background of the software-defined networking. So now here is the definition of software-defined networking. It is an immersed technology as well as organized networking. In the fast-changing scenario of networking, it's playing a vital role because SDN provides the dynamic nature of this your network, and at the same time, this is very intelligent because they can serve any types of networks. And at the same time, the basic aim of the any users, they will access the network with the low cost. So as well as SDN is will the suitable candidate for the future network also, because they can provide the interface between software and hardware parts. Now, why SDN? It is possible this data traffic management by conventional networking. So before we will go in the details, please remember my Guru mantra. In any time, anyone will ask how you can define the SDN and how it will differ from the conventional network. So let us take your example, you as a SDN network, how your mind and your different parts, head, leg, and different thinking, all are controlled by your mind. That is, in SDN, control plane and data plane are separate. But in the case of conventional network, both will exist at the same time, same parts. So what is the difference? So if your mind is controlled to your different parts of the body, or every parts will play independently, which one is the better controllable? Which one the better traffic management? Please think. So please remember, please don't read any unrealistic data. If anyone asks about the SDN, just think about yourself. Your mind is control and your different parts of the body is the data plane. So data plane is everywhere, but control is only one place. Please remember this. I can give other examples. If there is one building, there is a three floor, first floor, second floor, and third floor. So if all control plane, data plane, and user plane on the same ground floor, so is this possible? Everyone can observe every moment? No. So let us assume now one person will go at the second floor, some person at the second floor, and maximum person at the ground floor. Because we know at the higher floor, the stability decreases. So very few person can be there. So controller, one of them. So controller on the third floor, data plane on the second floor, and user at the ground floor. Now see, controller can see the overall picture of the network, and then they control fantastically. Data plane can see the users, and users can control. A data plane can control the users, in a very good manner. So this is the difference. So anyone in the life just ask you, can you define the SDN? Please think. You are the SDN. Your mind is a controller and different parts of the body is your data plane. So what is the difference? In conventional network, controller and data plane reside at the same place. But in the software-defined networking, control plane is at the top at the top positions. After that, data plane and then user planes. This is the basic or always remembering things so that you can never confuse. If you any times if you don't remember this body concept, then please think about the stability concept. First floor, second floor, and third floor. Third floor can manage the second, can able to see all these activity on the second floor. Second floor people can see all the activity on the first floor. So controller at the highest level, then the data plane, then the user plane. So hopefully you all are able to understand what the difference between conventional network and SDN networks. As, as far as the for the examinations or for the bookish knowledge, I have also regained some the basic concept. In conventional network, both data and control planes are lying on the same node. Whereas dedicated algorithm and set of rules are embedded in its firmware for the monitor and control the flow of the data in the network. That is known as flow agent. How? So I'm not able to read this information. You can read out. I'm here to give the guru mantra and basic concept. So how control plane communicated with the data plane, and many books, and you refer a lot of research papers or books, you are never find the different basics, difference between control plane and data plane. Data plane, I think no one has defined. Just given the idea about data plane and control plane are both are different. So in the next slide, I will give it the idea of both. So see, so control plane work is administrative the traffic, configurations, system control, and management. And data plane, application traffic, routing, load balancing, and observability. This is the basic working difference between the control plane and data plane. So is this possible? All are working on independently? No. Control plane is the master, and data plane will communicate with the control plane with the API, CLI, etc. And the control plane can monitor the traffic in uh, different uh, ways, and that will can explain in the architectures. So this is the historical function or evolution of the SDN. The details have been incorporated in my research paper also. I will provide the link. So here there is one very good concept in OpenFlow network. SDN is not covered without the OpenFlow. So again, I will give the basic concept about the OpenFlow. Since we all are aware, the OSI layer have the 7 different parts, 7 different layers, and all are physical layer to application layers. And so from first layer to 7 layer, the header will be added, and from top to down, again here will be eliminated. So error control, flow control, I think you are aware of that. That's one. So what is the role of OpenFlow networks? Now name itself, see, OpenFlow. So a different researchers have came with some solutions. If we will change some configuration OSI layer, so the network will support this 40 Gbps and up to 160 Gbps data as far as optical communication concerned. But I already told, to change the infrastructure is very difficult task. So OpenFlow is the network. They will just incorporate with the existing OSI layer without any change in infrastructure. And OpenFlow, that is the control plane, data plane, and user plane. This is the concept with the OpenFlow networks. And I will give the details about the OpenFlow networks in upcoming lectures when we have incorporated SDN with the IoT. Now, I will explain the key features of the software-defined networkings. So I already told separate control plane from the data plane. That is, your mind is independent from your body parts. If your hand wants to catch something, then instruction will goes to the control plane, that is your mind, and that will be interfaced with the API or CLI. A centralized control have global view. That is, you are in the third floor, you are able to see second floor and first floor. I already explained. Open interface between the devices in the data plane and the control plane. Yes. Yes, reconfigurable programmability of the networks by the external applications. Aggregate traffic management. Yes, this is the basic concept of the SDN. They can segregate the traffic in a fantastic way, because they are knowing which parts have which type of traffic, which type have the video traffic, which portions have the voice traffic, which portions have the data traffic. So they are able to see left side, right side, middle portion, which areas is incorporated the traffic load. So they will do the load balancing by the help of OpenFlow, by the help of data plane. So I already in the previous slide I already told that there's a load balancing of the role by the data plane by the help of control plane. Data plane have no independent role. Now here is the architecture of SDN, that is incorporated with the infrastructure, controller, and applications. So SDN have the three platforms: infrastructure, controller, and applications. So infrastructure, switches, routers, optical switches, wireless access point, base stations, all are incorporated in the infrastructure. And infrastructure will communicate with the controller. And there are two very popular, in SDN. Please remember, two controller is very important: NOx and POX. And if anyone wants to do the programming, I will help to configure the OpenFlow, and they can also uh, create their own SDN network by using NOx and POX. And I have already written 2-3 papers and 1 books on OpenFlow networks. If anyone wants, I will share that papers. And in that paper, I have given the idea how you can create your own SDN. If you are good in Linux, so you are able to create your own SDN networks. So here we are able to see controller westbound, and here is eastbound. Both are Knox, POX is there, Nestro, Onyx is there. But most popular is here. I have mentioned only POX, but Knox is also very important. And here is northbound, north, west, east. And here northbound is very important because I already told there is a API. Is very important. For always remember that CLI and API is the interface from data plane to controller, and same as the controller part to applications. And application is any type of traffic intelligence network, mobility network, access network, any types of applications can be incorporated with the SDN networks. So uh, next lecture, in the next video, I will incorporate the actual example of SDN with the IoT networks. In this slide, we have proposed the proposed architecture of software-defined heterogeneous networks, and you are able to see here the top view is the SDN controller, here the infrastructure networks, and here the OpenFlow protocol. This part, all part are data plane, and this data plane is communicated with the users. So users here, users. So in the top controller, then the data plane, and in the lower part is the client users. So this is the typical view of the SDN networks. So uh, in this lectures, uh, I have covered the basic concept of the SDN. So uh, I just conclude how you can define the software-defined networking. Software-defined network is reconfigurable, programmable, uh, and that can be interface with the that can control any type of traffic, because in current scenario the traffic load is very high. So how you can control to the SDN, and how you can define the SDN. So SDN is yourself, your full body is an example of SDN. So your mind is controller, your different parts is your uh, data plane, and if you uh, throw a ball, catch the ball, do the batting, that part is the user. So user is directly connected with the data plane, and your body will send the informations with the API and CLI to your mind, that is your controller. And for the bigger pictures, if you want to more uh, uh, typical view of the SDN, then please always remember my concept about the top floors, second floor, and first floor concept. Third floor, second floor, and first floor concept. The first floor is the more stability, the more users is there. Then second is the lesser stable than your ground floor. So the data plane, and the highest, very few people are there. That is the controller, and controller can the top view, they can able to see the entire traffic, left bound, north, south, east, west, and they can able to control the traffic. So this is the basic concept of the SDN, and I think after this, please, if you want to refer some books, papers, research papers, is okay. I will also share with one, but always remember SDN is your own body is your SDN. So hopefully uh, you understood this concept, and stay home and be healthy. All the best.